Okay, let's plan this out. We have problem identification, boundary condition, and challenge. Looking at the situation, the village is separated from the farm by a 45 meters river. The bridge is needed for the villagers to farm and bring their harvest back to the village. As for the boundary condition, only paper and masking tape are provided to build a 100th scale model to cross a 45 centimeters gap. Also, there is a need to ensure that the bridge is built in frame so that a S-hook can be hung in the middle of the bridge for testing. The model should support a total load of 6 kilograms to indicate the bridge design is safe for use. The challenge here is to design an efficient bridge which is expressed by the ratio of load over the weight of the bridge. It is known that there is a need for a bridge to connect both riverbanks. When people walk across the bridge, there will be a load applied on the bridge. When a load is applied, there will be a reaction force to counter the load, and because the forces are acting at different points, causing the bridge to bend. As the bridge bends, it is stretched, which is known as tension. If the bridge gets bent too much, it breaks. In order to keep the bridge safe to use, there is a need to design a compressive structure to counter the tension. Predict how the bridge design will fail, and estimate the load at which the bridge model will fail. To assist the activity, there are 2 tips. First, when using a sheet of paper, the paper has no strength. As the paper is pushed from both ends indicating compression, the paper will bend. When the paper is rolled, it can no longer be pressed as easily from both ends. Make sure it is in perfect roll. If there is a crease along the roll, the point of crease will be the weak point. Second, the joining of paper rolls. A triangle is more stable than a square. Try to push a triangle at 2 points and see if it deforms. Now try the same thing on a square. The shape gets deformed easily, indicating the shape is not stable. A square frame can be stabilized or resist any shape deformation by adding a diagonal member called bracing. Okay, with these tips, let's get started.